Here's a combination of operator and operand. After calculation, it will generate a result. That is nothing but expression. In between the variable, if you have the symbol that is operator, then it can be called as infix expression. If array represents n minus 1, then it indicates Q is full. The pointer head contains the location of the first element in the linked list. Welcome back to one and all. Myself, Vasanta, lecturer in computer science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysuru. Today, we are going to start with 8th session of data structure chapter. Whereas already in the previous session, you come to know regarding what do you mean by stack, that is collection of items where insertion of item as well as removal of item will take place at the same position, then array representation of stack, then linked list representation of a stack, then which are the operations that in a stack we can able to perform, algorithm for push operation, algorithm for pop operation, as well as application of stack. Regarding that already you came to know in the previous session, whereas on today's session you will come to know regarding arithmetic expression, queues, types of queues, operations on queue, memory representation of a queue using array, memory representation of a queue using linked list. Then what do you mean by expression? Expression in this, it is a combination of operand as well as operator. After evaluation, it will going to generate a single result. For example, here consider we have 2 plus 3. It is a combination of operator and operand. This is the operator. The symbol which we are using that can be called as operator. And the variables can be called as operands. Whereas an expression is a combination of operands and operator that after evaluation it generates a single result. When we come on expression, there are 3 types of expression: infix expression, postfix expression, as well as prefix expression. Whereas expression is a combination of operator and operand. The variables which we are using, for example, a plus b. Here a and b can be called as operands and this plus operator can be called as operator. Here's a combination of operator and operand. After calculation, it will generate a result. That is nothing but expression. 3 types of expression: infix, postfix, as well as prefix expression. Now one by one we'll discuss what do you mean by infix expression. If an operator is in between 2 operands, is called it as infix expression. For example, here I'm going to take A and then B. In between the variable, if you have the symbol that is operator, then it can be called as infix expression. If an operator is placed in between, 2 operands, then it can be called as infix expression. Example, A plus B. Then postfix expression. What do you mean by this postfix expression? For example, first I am having A and B, the variables. Then afterwards, if you have the operator, then it can be called as postfix expression. If an operator follows 2 operands, is called it as postfix expression. And the next one is prefix. In the beginning itself, we have the operator and then later on we have operands. Then it can be called as prefix expression. In prefix expression, if an operator placed before 2 operands is called as prefix expression. Example, plus AB. When we come on expression, it is a combination of operator and operand. After evaluation, it generates a result. 3 types: infix, prefix, postfix. In infix, the operator is placed in between the variable. In postfix, the operator is placed after the variables, whereas prefix, the operator is placed before the variables. These are the 3 types of expressions. Now, consider how to convert infix expression to prefix expression, prefix to postfix, that how to convert that. Regarding that, now we're going to tell you. For example, consider an example in fixed expression a plus b into c minus d into e into postfix expression. Here postfix we want to convert. Here it is infix expression because in between the operands we have operator. Then here CD, here in between we have the symbol, and then in between the variable we have star operator. From that I can say that it is infix expression. We want to convert that into postfix expression. Postfix means, already I told you, we have the operator will be present at the end after the operands. Here consider, if I want to convert any expression from one fix to another fix, on that time we have to follow some rules and regulation. Always we have to start executing the problem from right side to left side. Then with that, here inner bracket first we have to solve one by one. Whereas here, if you observe here, in the first step, what we have done, just I converted a plus b, here we have, that we are going to converting into ab plus. ab plus, the remaining thing as usual, we'll write into c minus d into e. Then in the second step, this part already we have completed. Next step, the inner bracket first we have to solve, then ab plus into cd minus into e. The second part also we have completed. Now here we have two star operator. Then first we have to convert this part. Then AB plus is one variable, CD minus is one variable, then star, then regular star into E. Now this represents one variable, and the last one E represents one more variable. Now we want to convert it to postfix. That's why AB plus CD minus into the first part we'll write, then E into, once again we'll write. This is the postfix expression for the given expression. Now consider one more example. Convert infix a plus b into c minus d into e. One more into prefix. The same question we have considered, but now we are converting this into prefix. On this case, first part we'll convert this one, plus ab first we'll write, then the remaining thing, that is star, cd, c minus d, then star, then e as usual we'll write. Then next we'll convert the second part. First we have to convert the inner part, especially in the bracket, whatever thing we have, that way to solve. Then plus AB into minus CD we are converting. That means we are converting this into prefix format into E. Now here also one operator, here also we have one operator. Now we have to convert this part, that is star, first operator will write plus AB minus CD. Then star E. Now this is one variable, then this one is one variable. Then once again we will want to write star into the first part, star plus AB minus CD, then E will write. This is the prefix expression for the given infix expression. It means that we can able to convert any infix expression to prefix as well as postfix. In the same way, postfix to any other format. In the same way, here whichever problems you have, we can convert from one prefix to another prefix or postfix, like that we can able to convert. Now, I want to explain regarding Q. Whereas in the previous class, you studied regarding what do you mean by stack? Which are the types of operations we can able to perform on stack? Regarding that, you came to know. Whereas now we want to explain Q. Whereas in stack, insertion of element as well as removal of element will take place at the same place. That place can be called as top of the stack. But when you come on Q, Q is a collection of item. If you come on array, there also is a collection of item. Whereas in array, the collection of item where all the items are of same data type. Whereas when you come on stack, stack is also a collection of item where insertion of item as well as removal of item will take place at the same position. But when they come on Q, whereas here in the Q, the collection of item, it is also a collection of item, but insertion as well as deletion will take place at different position. For example, consider a one Q. On this Q, consider the elements position 0, 1, 2, 3, 4. Then here I am having the value A, B, C, D, E. Whereas insertion of item will take place at rear position and deletion of item will take place at front position. Whereas Q is a ordered collection of items where the addition of new item, that means insertion of new item at one end called rear end. The place where we are inserting, that place can be called as rear end. And an existing item is removed at another end called front end. From this place we can able to remove. It means that insertion of element as well as removal of element will take place at different position in a queue. Whereas in stack, insertion as well as deletion will take place at the same position, whereas here in different position insertion and deletion will take place. If you observe this, here Q maintains first in, first out, that is Fi, Fo. Consider we have one more Q. Here we have the position 0, 1, 2. Whichever element first we are inserted, that will come and here stand here. Then second element, then third element. While removing, first I am to remove A, then later on B and then C. It means that whichever is first in, the same one will be first out. That is first in, first out, last in, last out technique. Here it will follows. First in, first out, order, priority, properties, or I can say last in, last out. Last in, last out also we can say. Consider the place where we are removing, that can be called as front. The place where we are inserting, that can be called as rear. Next, when we come on types of queues, there are 4 types of queue. One is simple queue, circular queue, priority queue, and one more is D queue. There are 4 types of queue: simple, circular, priority, and D queue. Now one by one we'll explain. The first one, simple queue. What do you mean by the simple queue? In simple queue, insertion of element will take place at rear position and removal of item will take place at front position. Consider this is the queue. Here insertion will take place at a rear position and removal of element will take place at front position. 0, 1, 2, 3. Here consider A, B, C, D. It means that now we are ready to remove the item A and the recent one which are inserted, that can be called as D here. Whereas in simple queue, insertion occurs at rear end of the list and deletion occurs at the front end of the list. Insertion takes place at rear and deletion will take place at front. And the second one is circular queue. What do you mean by this circular queue? In the circular format, once again the last follows front or the front one follows the last one once again in a circular format. That is, in circular queue, a circular queue is a queue in which all nodes are treated as circular such that the last follows the first node once again. The last one once again follows the first one or first one follows the last one once again. That can be called as circular queue. And the next one is priority queue. What do you mean by this priority queue? In priority queue, the items have some priority. An element can be inserted or removed from any position depending upon some priority. We have the queue elements. Here, for example, A, B, C are the element. Here, position wise 0, 1, 2, 3. On whichever position I want, on that position I can able to insert. And whichever position I want, there I can able to remove here. That is priority queue. It means that the items which having priority, only that item can be inserted as well as removed in any position of the queue. I am going to give an example for that. Consider in simple queue, you want to pay current bill. Consider you want to pay current bill. Then on the queue you will stand. Then this is the, for example, service counter. The first one who is in the standing in the queue, first one service, then second one, third one, fourth one. That is simple queue. Whereas circular queue, once again, the first one follows the last one or last one follows the first one. But when they come on priority queue, the person which having the priority, only the person, the item which having priority, that item can be inserted as well as removed any position. If they want, they can insert at the front as well as in rare. In both the place they can able to insert as well as they can able to remove here. In this priority, the items which having priority, only that items can be inserted any side or it can be deleted in any side. And the last one is DQ, that is double-ended queue. DQ can also be called as double-ended queue. It is a queue in which insertion and deletion takes place at both ends. There is a difference between priority queue and DQ, whereas in DQ, in both the side, all the elements can be inserted as well as removed. Whereas in priority queue, only the items which having priority, only that item can be inserted as well as removed in any position, where it may be rear position or it may be front position. Whereas here, any element can be inserted as well as deleted from both the place. Whereas in priority queue, only the items which having priority, only that item can be inserted as well as removed at both the position. Next, which are the major operations in a queue we can able to perform? In the stack also, I told you it is very important question because in the exam you may going to get the question, write the operation of stack. In the same way, you may going to get the question, explain the operation of queue. It is very important question. Whereas when they come on the operations, the first one is queue function. What is the use of this queue function? It helps to create one empty queue. It helps to create one empty queue. Here we are not inserting any item or we are not deleting any item. Just it creates new queue that is empty. Next one, NQ. NQ here, item. Inside the bracket for NQ function, we are writing item. Which is the item we are inserting? Consider I want to insert one item. I am going to insert at the position, whichever position here. When I am going to insert, that item will come and sit here. For example, A. That means NQ is add a new item to the rear of the queue, and this operation is also called as push function. Adding a new item to the queue is nothing but NQ. For example, here I am having B, C, D. Then this is the front. For example, here I can able to remove an item. Whereas DQ is nothing but remove item. Remove the front item, especially whichever item in the front, that item we are removing. Front item from the queue. This operation is called as pop operation. Whereas only for push operation, we have to mention which is the item we are inserting. That's why here we are writing item. Whereas for the remaining function, we are not writing anything inside the bracket. And the next one is empty function. This function will check whether the queue is empty or not. It will not adding any item or it will not remove any item. It just check whether the queue is empty or not. This tests whether the queue is empty or not. And the next function, size function. This function returns the number of items in the queue. Especially on the queue, how many items are there? Regarding that, it will going to tell you. There are 5 major operations that can be performed in a queue. The first one is queue function, helps to create new empty queue. Then NQ function helps to add a new item to the rear position of the queue. Whereas DQ is nothing but removing an item from the front of the queue. Whereas E is empty, it checks whether the queue is empty or not. Then size function helps to identify the number of items in the queue. Now is it clear for all of you? Next we will move on the memory representation of a queue using array. How to represent in the memory? When you come on stack, there also in 2 methods we can able to represent. One by using array method and one more by using linked list method. The queue also can also be represented in 2 methods, one by using array method and one more by using linked list method. Now first we'll discuss about by using array method how to represent. Queue is represented in memory in linear array format. What do you mean by linear? In continuous memory location, in adjacent memory location, we can able to store all the elements. Consider this is the queue. On this queue, we have the values A, B, C, D, portion wise 0, 1, 2, 3. This is rear and this place can be called as front. If you observe here, if rear equals, that is here 3 I given, n minus 1, it means that the queue is full. Consider one empty queue, portion wise 0, 1, 2. If front represent minus 1, it means that here if you don't have any elements, then front represents minus 1. If it is full, then the last one, that is n minus 1, represent the rear, then it means that it is full. If front represents minus 1, then it is empty. Whereas it having two pointer variables, front as well as rear. One is front and one more is rear. Two pointer variables we have. A pointer variable front contains the location of the element to be removed. Whichever element now we want to remove, it contains that address. Here it stores the recent value which we want to remove. That address it will store. The pointer variable rear contains the location of the last element inserted, which is the recent element we are inserted. That element address it stores. Whereas front contains the recent, now whichever now we want to remove, that address it can store. If a front equals null, I can say it as minus 1, then Q is empty. See here in this case, if a front represents minus 1, it means that Q is empty. If rear represents n minus 1, then it indicates Q is full. See, if you observe, if rear represents n minus 1, then Q is full. If front as well as rear both if represents minus 1, it means that the Q is empty. For example, consider the array elements. The portion was 0, 1, 2, 3, 4, 5, 6, 7, 8. Totally it can store 7 elements, but here I given only A, B, C, D. Here, front as well as rear. Now, for example, here we have A. This A represents the front. That is, here, this represents the front value. And here, this 4 represents the rear value. Now, is it clear? Like that, we can able to queue element in the array method also. But here, the major drawback here, I cannot able to increase the size as well as decrease the size at the run time. For example, maximum I can able to store 9 elements. If it is more than 9 elements, here it is not possible in array method. To overcome from that, we required a linked list method. Maximum, consider here one queue we have. Here A, B, C, D, position wise 0, 1, 2, 3. Consider I can able to store only 4 elements here. If I want to insert 5 elements, here it is not possible here because the capacity itself 4 elements. To overcome from that problem, we need linked list because at the run time, I cannot able to increase the size as well as I cannot able to decrease the size. Now, when you come on memory representation of a queue using linked list, queues are also represented using linked list, it having two pointer variable front as well as rear. As usual in array method, how we have two pointers, in the same way here also we have two pointer variable. One is front and one more is rear. The pointer head contains the location of the first element in the linked list. The head contains here, this is the head contains the address of the first one. The pointer rear contains the location of the last element. This is the last element, that is 30 is the last element. It means that in the linked list, it is a collection of nodes. This is one node, this is one node, this is one node. Collection of nodes. Each node contains two parts. One is data part and one more is address part. In the data part, it contains actual information. In address part, it contains address of the next node. If the address part contains null, it means that that is the last node. Now is it clear? Then next class, you will come to know which are the operations in the queue we can able to perform, like NQ operation, DQ operation, algorithm, how to write the algorithm as well as how to write the program on that is NQ as well as DQ. Then which are the major functionalities of this, the application of queues. Regarding that, you will come to know in the next session. Thank you for all of you.